has confirmed it's launched an attack on Iran.
30 seconds. That's all it takes for a regional standoff to transform into a moment that could redraw the balance of power across the Middle East. In this dramatized reconstruction of a hypothetical US-Iran confrontation, what begins as a routine military patrol quickly escalates into one of the most dangerous aerial encounters ever imagined. Intelligence reports suggest heightened alert levels across the Persian Gulf after an unidentified radar signature appears near a restricted flight corridor. Iranian air defense operators interpret the signal as a potential strike formation. Across the horizon, unseen and almost silent, a single F-35 Lightning II moves through contested airspace, its presence known only to satellites and encrypted command networks thousands of miles away. Minutes earlier, both sides were engaged in what analysts call strategic signaling: naval movements, surveillance flights, and electronic probing designed to test reactions without crossing the line into open conflict. But history has shown that modern warfare rarely announces itself. A misread transmission, an aggressive maneuver, or a delayed confirmation can collapse diplomacy in seconds. According to simulated defense assessments, an Iranian interceptor squadron launches to investigate the anomaly, unaware that advanced stealth technology has already shifted the tactical equation. Radar systems begin sweeping the skies at maximum power, searching for a target that technically isn't supposed to exist. Inside the cockpit, data flows faster than human perception. Sensors fuse infrared tracking, satellite intelligence, and electronic warfare signals into a single battlefield picture. The pilot doesn't see chaos, only probabilities. Every movement is calculated, every second measured against escalation protocols designed to prevent catastrophe while preparing for it at the same time. On the ground, command centers debate whether this is a show of force or the opening move of something far larger. Communications spike, warning channels activate, regional allies scramble to interpret events unfolding too quickly for diplomacy to catch up. Then comes the decisive moment. A weapons lock warning flashes across multiple systems almost simultaneously. Defensive networks react automatically, interpreting intent before confirmation arrives. In modern aerial warfare, hesitation can mean vulnerability, and vulnerability can mean loss of control. Analysts estimate that from detection to response, fewer than 30 seconds separate peace from confrontation. The skies become a chessboard played at supersonic speed, where invisibility, electronic deception, and split-second judgment determine survival. What makes this imagined encounter so unsettling is not the firepower involved, but the speed at which escalation becomes irreversible. Billions of dollars in technology, decades of geopolitical rivalry, and the fragile stability of an entire region converge in a single airborne decision. Military experts warn that future conflicts may not unfold over days or weeks, but in moments too brief for world leaders to intervene. Tonight, we break down how such a confrontation could unfold, why advanced stealth aircraft have changed the rules of engagement, and how one critical miscalculation might trigger consequences felt far beyond the battlefield. Because in modern conflict, wars may no longer begin with declarations, but with 30 seconds no one can take back. In the hours leading up to the confrontation, the skies above the Persian Gulf carried a tension that could not be seen on radar screens, but was felt across every command center in the region. For weeks, relations between the United States and Iran had been deteriorating following a series of naval incidents near vital shipping lanes. Commercial tankers reported aggressive flyovers, surveillance drones were repeatedly intercepted, and electronic interference disrupted civilian navigation systems along the Strait of Hormuz, one of the most strategically important waterways in the world. Nearly 20% of global oil shipments pass through this narrow corridor, making even minor military movements capable of triggering worldwide economic shockwaves. According to publicly known defense patterns, the U.S. Navy had increased its presence in the region, deploying carrier strike group assets supported by airborne early warning aircraft and reconnaissance platforms. Official statements describe these deployments as defensive measures intended to ensure freedom of navigation. At the same time, Iran's Islamic Revolutionary Guard Corps intensified air defense drills along its southern coastline, activating layered radar systems designed to detect both conventional aircraft and low observable targets. Analysts have long noted that Iran relies on a combination of domestically produced systems and modified Russian-designed radar technology, creating overlapping detection zones meant to complicate foreign air operations. What made this particular night different, however, was the sudden spike in electronic activity detected by monitoring stations across Qatar, Bahrain, and Kuwait. Signals intelligence units reportedly intercepted encrypted transmissions, suggesting that Iranian air defense forces had shifted from routine monitoring to combat readiness posture nearly 6 hours earlier than scheduled. Some experts later speculated that Iranian commanders believed a reconnaissance mission was preparing to cross an unofficial red line established after previous drone encounters in the region. Satellite imagery from commercial providers appeared to show interceptor aircraft moved onto active runways at Bandar Abbas Air Base, engines prepared for rapid launch authorization. Meanwhile, U.S. airborne assets conducted what defense officials would classify as a presence patrol, a mission designed to demonstrate capability without initiating confrontation. The F-35 Lightning II, widely regarded as one of the most advanced multi-role fighters in service, had already transformed aerial strategy through sensor fusion and stealth design. Its ability to gather intelligence while remaining difficult to detect allows it to operate closer to contested airspace than previous generations of aircraft. In real-world doctrine, such flights are often coordinated carefully to avoid escalation, yet the margin for misunderstanding remains dangerously thin. Unconfirmed regional reports later claimed that a temporary failure within a coastal radar relay station caused Iranian operators to misinterpret multiple airborne signatures as a coordinated strike package rather than a single reconnaissance platform. Though never officially verified, defense simulations suggest that atmospheric conditions over the Gulf, including temperature inversion layers known to distort radar reflections, may have amplified electronic echoes, creating phantom targets on tracking displays. Operators suddenly faced what appeared to be several incoming aircraft approaching sensitive military infrastructure. At nearly the same moment, civilian air traffic controllers recorded brief communication delays affecting transponder identification signals across part of the air corridor. Aviation specialists believe routine electromagnetic interference could explain the disruption, but within a high-alert military environment, ambiguity becomes threat perception. Iranian command units reportedly elevated readiness levels, authorizing interceptor crews to stand by for immediate scramble orders. Across the water, U.S. monitoring systems registered the change instantly. Data links relayed updates through secure networks connecting airborne pilots, naval commanders, and regional operations centers stretching as far as Europe. What neither side fully understood was how quickly automated defense logic and human caution were converging toward confrontation. Modern militaries rely heavily on rapid response frameworks designed to prevent surprise attacks. Yet those same systems compress decision-making timelines. Intelligence officers later described the situation as a classic escalation trap, both sides acting defensively, both interpreting the other's caution as preparation for aggression. Within minutes, surveillance aircraft adjusted their flight paths, radar systems intensified scanning cycles, and missile batteries shifted from passive monitoring to tracking mode. By the time the first warning indicators appeared inside military cockpits, the confrontation had already begun psychologically, long before any weapon system activated. Pilots on both sides entered what training manuals describe as the threshold phase, the moment when uncertainty gives way to irreversible action. The sky remained silent, but every sensor, satellite, and command console pointed toward the same conclusion. One miscalculation now stood between deterrence and combat. The turning point came not with an explosion or missile launch, but with a decision made in less than 3 seconds inside a dimly lit air defense coordination center along Iran's southern coast. Operators monitoring long-range radar arrays had already been tracking unusual activity for nearly 20 minutes, when one of the surveillance consoles registered what appeared to be a sudden change in flight behavior. The unidentified contact, previously moving parallel to international airspace boundaries, altered its trajectory by just a few degrees. A maneuver insignificant under normal circumstances, yet deeply alarming in a region operating under heightened military alert. In modern air defense doctrine, even minor deviations can signal targeting preparation or electronic reconnaissance aimed at mapping defensive weaknesses. Iran's integrated air defense network, built over decades to counter technologically superior adversaries, relies heavily on layered confirmation before escalation. Systems combining ground-based radar, passive detection receivers, and infrared monitoring attempt to distinguish civilian traffic, surveillance platforms, and potential strike aircraft. However, stealth aircraft challenge these assumptions by reducing radar visibility rather than disappearing entirely. Instead of a clear signal, operators often see intermittent returns, brief flashes that appear and vanish across multiple screens. On this night, those fragmented signals began aligning in a way that suggested coordinated movement rather than random interference. According to later analytical reconstructions, a secondary radar positioned near Keshem Island briefly detected what technicians classified as a high-confidence anomaly. The contact speed and altitude profile matched known characteristics associated with advanced fifth-generation aircraft. Although such detections are typically treated cautiously, simultaneous electronic noise detected across communication bands complicated interpretation. Some analysts believe a scheduled electronic warfare exercise conducted hundreds of kilometers away unintentionally contributed to signal congestion, masking identification data normally used to prevent miscalculation. Within seconds, uncertainty transformed into perceived threat. At 2:14 local time, interceptor crews stationed at Bandar Abbas reportedly received preliminary scramble authorization, not an order to engage, but permission to prepare for rapid launch. Fighter pilots moved to cockpits while ground crews disconnected external power units. Across the Gulf, U.S. command networks instantly registered increased Iranian airbase activity through infrared satellite monitoring, capable of detecting engine heat signatures even before aircraft left the runway. Such surveillance capabilities are well documented and form a central component of modern early warning systems. The critical miscalculation occurred when an automated threat assessment algorithm within the regional defense network categorized the unidentified aircraft as transitioning from surveillance posture to potential strike alignment. While human confirmation is normally required, heightened readiness protocols shortened verification procedures. A warning transmission was broadcast on an emergency military frequency, instructing the unknown aircraft to alter course immediately. Due to the nature of stealth operations, however, the aircraft maintained radio silence, following standard operational security procedures designed to avoid revealing position or mission intent. From the Iranian perspective, silence confirmed suspicion. Within command channels, debate lasted less than a minute. Some officers argued the contact was testing response times, a tactic previously observed during intelligence-gathering missions. Others warned that hesitation could allow a precision strike platform to approach sensitive installations undetected. Historical memory played a role as well. Past incidents involving drones and surveillance aircraft had conditioned commanders to expect rapid escalation once airspace boundaries were challenged. Meanwhile, inside the cockpit of the approaching aircraft, advanced sensor fusion displayed a rapidly changing tactical environment. Radar emissions intensified below, surface-to-air tracking systems shifted frequencies, and multiple targeting radars briefly illuminated the aircraft's defensive warning receivers. These signals indicated that ground defenses were no longer searching blindly. They were attempting active lock procedures. Standard protocol required immediate reassessment. The pilot transmitted encrypted updates through secure data links rather than open radio channels, allowing commanders to evaluate whether to withdraw or maintain course. Then came the moment that pushed both sides beyond caution. One Iranian interceptor, launched under defensive authorization, accelerated toward the contact zone faster than expected due to favorable atmospheric conditions and reduced payload weight during training configuration. U.S. monitoring systems interpreted the rapid climb as a possible engagement vector rather than identification maneuver. Defensive systems aboard the stealth aircraft automatically prioritized the approaching fighter as a potential threat. In less than 30 seconds, layered defensive reactions on both sides overlapped. No missiles had been fired, yet targeting solutions were forming, countermeasures preparing, and pilots transitioning mentally from observation to survival. What began as a defensive response to uncertainty had evolved into mutual escalation, driven not by intent, but by technology, compressing human judgment into impossible timelines. At that point, disengagement was still possible, but every passing second made restraint harder than action. As the situation crossed from confrontation into active engagement, the aircraft at the center of the unfolding crisis finally revealed its decisive advantage. Not through visibility, but through absence. The F-35 Lightning II entered the contested airspace envelope, operating exactly as it had been designed, not as a traditional fighter relying on speed alone, but as a flying intelligence node capable of dominating the battlefield before opponents fully understood they were already part of it. Earlier tensions had already pushed regional defenses into maximum alert, and now every radar emission, communication burst, and aircraft movement fed directly into the F-35's sensor fusion system, constructing a real-time digital model of the entire battle space. Unlike older combat aircraft that require pilots to interpret separate radar, targeting, and navigation systems, the F-35 merges information automatically, presenting threats as prioritized decisions rather than raw data. At high altitude above the Gulf, the pilot watched hostile tracking zones expand across the display as Iranian interceptor aircraft advanced from multiple directions. What made the encounter uniquely dangerous was that neither side initially possessed a clear visual confirmation of the other. The Iranian fighters relied primarily on ground guidance vectors and intermittent sensor returns, while the stealth aircraft maintained passive detection modes, observing without broadcasting detectable signals. Fifth-generation aerial doctrine emphasizes first awareness rather than first shot. By the time Iranian interceptors reached operational altitude, the F-35 had already identified engine signatures, radar patterns, and probable weapon configurations through distributed aperture sensors capable of detecting thermal contrasts across vast distances. Analysts often compare this advantage to seeing an opponent through walls while remaining invisible oneself. Yet stealth is never absolute. It reduces detection range rather than eliminating it entirely. As distances closed, Iranian airborne radar systems began registering faint, unstable contacts. Enough to trigger pursuit, but insufficient for reliable targeting solutions. Pilots approaching the area reportedly executed wide search patterns, intended to force the unknown aircraft into revealing itself through maneuvering. Such tactics are common when confronting low observable targets, attempting to compress escape routes and increase detection probability. The airspace rapidly transformed into a high-speed geometry problem, unfolding across dozens of kilometers. Each turn altered radar angles, each climb shifted infrared exposure, and every transmission risked revealing intent. The F-35 responded with calculated precision, adjusting position minimally while relying heavily on electronic warfare capabilities designed to distort incoming signals. Defense analysts have long noted that modern aerial combat increasingly resembles cyber conflict conducted through electromagnetic space rather than visible dogfights. Ground-based tracking systems intensified scanning cycles, briefly synchronizing multiple radar frequencies in an attempt to overcome stealth shaping. For several seconds, the aircraft's warning receivers indicated partial illumination, a sign that defensive networks were approaching viable lock conditions. Inside the cockpit, automated threat management systems recommended countermeasures even before pilot input. The aircraft subtly altered its orientation, reducing radar cross-section exposure while deploying low-power electronic interference bursts, intended to confuse targeting algorithms without escalating to overt jamming. The encounter reached its most volatile phase when one interceptor achieved temporary sensor correlation using combined radar and infrared tracking. Though not stable enough for missile guidance, the detection narrowed uncertainty dramatically. Both pilots now understood that proximity alone could force escalation. At supersonic closing speeds, reaction windows shrink to seconds. Training emphasizes immediate decision cycles known as the OODA loop: observe, orient, decide, act. But modern sensor automation compresses this process beyond natural human tempo. The F-35 pilot received confirmation that weapons authorization thresholds were approaching under defensive engagement rules. Simultaneously, interceptor aircraft adjusted formation spacing, attempting to bracket the contact zone. Tactical analysts later suggested this maneuver unintentionally increased risk by creating overlapping targeting responsibilities, raising the probability that one pilot might interpret defensive movement as hostile initiation. Communication delays measured in fractions of seconds began to matter. Radar warnings pulsed intermittently, indicating attempts at missile queuing even without confirmed lock. At this stage, every participant operated under incomplete information. Iranian pilots faced an opponent they could neither clearly see nor reliably track, while the F-35 pilot monitored multiple potential threats converging simultaneously. Heat signatures from afterburner bursts appeared briefly against the night sky, visible through advanced optics long before human eyesight could register them. The aircraft's onboard systems calculated engagement probabilities continuously, highlighting escape vectors, counterattack options, and survivability outcomes. Then came the decisive seconds that defined the encounter. One interceptor accelerated aggressively in what ground controllers later described as an identification pass, intended to force visual confirmation. From the stealth aircraft's perspective, however, the rapid approach matched known engagement profiles associated with missile employment positioning. Defensive logic triggered automatically. Target prioritization shifted from monitoring to response readiness, and weapon systems transitioned from standby to active tracking mode. Modern air combat rarely resembles cinematic dogfights. Instead, victory often depends on who controls information flow. The F-35 briefly activated targeting sensors optimized for minimal detection, establishing firing parameters while still outside conventional engagement awareness. At the same time, electronic countermeasures introduced false positional data into hostile tracking systems, creating slight discrepancies between perceived and actual location. These discrepancies, measured in mere meters, can determine whether a missile finds its target or misses entirely. For nearly 15 seconds, both sides hovered at the edge of irreversible action. Pilots maneuvered within invisible boundaries defined by rules of engagement, survival instinct, and automated warning systems designed to protect them. The airspace filled with overlapping radar cones, encrypted transmissions, and predictive targeting calculations occurring faster than conscious thought. Later simulations suggested that had either aircraft deviated marginally more, by altitude, speed, or vector, the confrontation could have escalated into immediate weapons release. Instead, the engagement evolved into a contest of pressure rather than destruction. The stealth aircraft executed a high-energy maneuver, exploiting its advanced flight control systems, slipping outside optimal interception geometry while maintaining sensor dominance. Interceptors momentarily lost correlation as electronic signatures fragmented across their displays. Within seconds, uncertainty returned to the battlefield, replacing imminent engagement with confusion. Those final moments demonstrated the defining reality of modern aerial warfare. Combat can reach its climax without a single missile fired. Billions of dollars in technology, years of pilot training, and national prestige converged in a silent struggle fought through algorithms, positioning, and perception. The battle was decided not by impact, but by who controlled escalation long enough to survive it.